Here we have a pre-calculus problem. Okay, let's go to the question. Find the value of x if log base x of 3 positive, log base x of 9 positive, log base x of 729 equals to 9. Okay, in the given equation, we have to solve for x. That is, we have to find the value of x. Okay, now let me take the given equation as it is. It is log base x of 3 positive, log base x of 9 positive, log base x of 729 equals to 9. Okay, now let me consider the product rule of logarithms. That is, let me add two logarithms with the same base. That is log base a of m, log base a of n. Okay, whenever I add two or more logarithms with the same base, what I can do is I can take logarithm once with whatever base I have for the logarithms, and now I have to multiply the arguments m and n. Okay, that is m times n. So this is a result of the addition of the two logarithms we have on the left side. So this is called product rule of logarithms, and we can extend this product rule for more than two logarithms when we add them with the same base. Okay, here on the left side of the given equation, we add three logarithms with the same base, that is x. So now what we can do is we can use the product rule. That is, we have to take logarithm once with the base what we have for all the three logarithms, and we have to multiply the arguments. That is 3 times 9 times 729. Okay, here on the right side, we can take this 9 as it is. Okay, here to solve for x in this logarithm, what we have to do is we have to convert this equation to exponential form. So already this equation is in logarithmic form. Now we have to convert this equation to exponential form to solve for x. How do we have to convert this equation to exponential form? For that, we have to consider the part which contains logarithm. So the stuff we have on the left side of the equation contains logarithm. Now let's take this logarithm along with the base x. It has to be moved to the right side of the equation. When I move this logarithm along with the base x to the right side of the equation, we have to ignore this logarithm. We have to consider only the base x on the right side. And the value which already exists on the right side, that is 9, will become exponent of this base x, that is x to the 9th power. Now we can write this stuff on the left side as it is, that is 3 times 9 times 729. Okay, here we know that 3 is a prime number, and this 9 is a power of 3, this 729 is also a power of 3. So 3 can be written as it is because it's a prime number, and 9 can be written as 3 to the second power. And this 729 can be written as the power of 3. For that, we have to decompose the 729 into the prime factor 3. Let me do it. 729. Let me divide the 729 by 3. So when I do so, I am getting 2 over here, and 4 and 3. Okay, let me divide it by 3. Then I am getting 81. Let me divide it by 3. I am getting 27. Let me divide it by 3. I am getting 9. Again, I divide by 3. 3. So 1, 2, 3, 4, 5, 6. That is, we can write this 729 as 3 to the 6th power. And on the right side, we can write this x to the 9th power as it is. Okay, for this 3, we don't have any exponent. Whenever there is no exponent, we can assume there is exponent 1. Okay, here we multiply 3 powers with the same base 3. Whenever we multiply 2 or more powers with the same base, what we can do is we can take the base ones and we have to add the exponents. Actually, this is a product rule of exponents. Okay, here when I add the 3 exponents, 1, 2 and 6, I am getting 9. Okay, on the right side, we have x to the 9th power. Now, two powers are equal with the same exponent, that is 9. Whenever two powers are equal with the same exponent, what we can do is we can equate the bases. Okay, when I equate the bases, I am getting 3 equals to x. Okay, here I got x equals to 3. That is, the value of x is 3. And we find this 3 in answer choice B. The correct answer choice for this question is B.